Welcome students, this is the video for January 9th on linear inequalities, and this is different than the single variable inequalities that we did earlier in the year because this is going to have two variables. These will have x's and y's in them, so it'll be kind of like the lines that we've been studying, except there's going to be some different things that will happen in there. Alright, so the definition of a linear inequality is a region on the coordinate plane that has a boundary line. Okay, so it's a region, which means it's an area of the graph, and a boundary line, it's kind of like an out of bounds line. It's just a line that sections off what we're talking about. The inequality symbols are the same as they were back in elementary and middle school. This is your less than. This is less than or equal. Your less thans look like L's. That's how we know that. And then your other two, this is your greater than, and this is greater than or equal. Okay. The next one is a definition of a solution to a linear inequality. The solution to an inequality are the coordinates or points that make it true. Okay? They're going to be the coordinates or points that are in this region that we talked about up here, but as far as the inequality itself, they're going to be the ones that make it true, make it a true statement. So example 1 here is we're going to prove that 1 comma negative 3 is a solution to this. So this is an x and that's a y, so anywhere we see x we're going to replace with a 1, so this becomes 2 times 1, plus anywhere there's a y we're going to put negative 3, 3 times negative 3, less than symbol, negative 2. And then we're just going to do the math behind here. 2 times 1 is 2. 3 times 3 is negative 9, is less than negative 2. Whoops. 2 minus 9 is negative 7, is less than negative 2. And this is a true statement because negative 7 is less than negative 2. Alright, so put one of these on the graph. Anytime we see something that's in a y equals form, it's going to be a line, and this is going to be the line that we talked about a little bit ago. This is the boundary line that we see. When we graph an inequality, we're going to put the inequality in slope-intercept form, so that just means we're going to get it into a y equals mx plus b, but the equal won't be an equal, it'll be an inequality symbol now, so it'll be less than or greater than, or less than or equal to or greater than or equal to. Well, then we're going to graph the inequality using the slope and y-intercept, so we're going to continue to find our m and find our b. B is where we start. M is how we move, just like we learned back in the first semester. We have some things to remember. We had these faces. Okay. And then we had this face. And these were to help us to know whether it's a dashed or dotted line or a solid line. So if it's less than or greater than, we use a dotted line. If it has the equal to part, we use a solid line. The last part is we do some shading, and that's what creates these boundaries. If it's greater than, we shade above. So this is greater. And if it's less than, we shade below. And that should kind of make sense because greater things are above, greater numbers are higher, less numbers are down below. Alright, so when we go to graph this, negative 1/2 is our slope, so negative 1 over 2. Our b is 0, 4. I look at the symbol here. This is a less than symbol. Less than gets a dashed line. Then I have to decide shade above or shade below. Less than is shade below. Alright, so when I go to start graphing this, I always begin with b, so I begin at 4. So I put a big dot there, that's my starting point. Then I'm going to move using the slope. So negative 1 means I go down 1 to the right 2. So down 1 to the right 2. So that's my next point. Down 1 to the right 2. That's my next point. Then I'm going to make a dashed line going through that. like that, and then I'm going to shade below. So everything down here is a solution. Okay? So then it asks you some questions. Can solutions be on the line? So if we were to check 0, 4 in here, 0 is the x, 4 is that. So we would put 4 out to the side. 4 is less than negative 1/2 times 0 plus 4. So I'm trying this point right here, 0, 4. Half of 0 is 0, so I get 4 is less than 4. This is not a true statement, so dotted lines do not work. So the answer is no. Solutions cannot be on a dotted line. Is 0, 0 a solution? Well, 0, 0 is located right there. That's in the shaded area, so that is yes. The other option would be to plug 0, 0 in, and it would look like this. 0 is less than negative 1/2 times 0 plus 4. That stays 0. Half of 0 is 0 plus 4 is 4. 0 is less than 4. That's a true statement. So 0, 0 is a solution. We're going to do the same thing on this one. We're going to find the m. It's 3, which will be 3 over 1. The b is negative 2. We're looking for a dashed or solid because this is the symbol. Then we're going to use a solid line. And then this is a greater than symbol. It's actually greater than or equal to. So that means we're going to shade up. So I begin at negative 2. So a big dot right there. I'm going to go up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. I'm going to use a solid line this time. And then I'm going to shade above. So that's this side right here, shade above. Okay. Can solutions be on this line? Well, again, we can try it. Right here's a point, 0, negative 2. If I plug that in, negative 2 is greater than or equal to 3 times 0 minus 2. So that becomes negative 2 is greater than or equal to 3 times 0 is 0. 0 minus 2 is negative 2. Negative 2 is equal to or greater than negative 2. So this is yes. So yes on a solid. Is 3, negative 2 a solution? Over 1, 2, 3, down 2. That's not in the shaded, so that is a no. That is not a solution. If we plugged it in, this is what it would look like. Negative 2 is greater than or equal to 3 times 3 minus 2. I plugged in a negative 2 for the y and a 3 for the x. So this is negative 2 is greater than 3 times 3 is 9 minus 2. 9 minus 2 is 7. Negative 2 is not greater than or equal to 7, so that's a no. So you have two options. You can look at the graph to see if it's a yes or no, or you can plug in. And if you have the graph, it's easier to look at the graph. But if you don't have the graph and you just have an equation, then it's easier to just check the equation. All right, here's some extra examples for us to work on and practice here. The difference you see here is this is not solved for y, so we have to solve for y first. So I draw my line there, or my box, draw my line. Subtract 1x from both sides. That cancels out. I bring down my negative 2y, bring down my greater than. Since I know I'm working towards mx plus b, I'm going to put the negative 1x part first and the 4 second. Then I'm going to divide everything by negative 2. Why? We learned a rule back in the first semester that says when you divide by a negative, you have to flip. So this symbol flips to greater than. Negative 1 divided by negative 2, math 1 enter, is 1/2 x. 4 divided by negative 2 is negative 2. So now I'm ready to find my m, my b, what type of line I have, and whether it's shade up or shade down. So in this case, my m is 1 over 2, which is up 1 to the right 2. My b is negative 2. My symbol looks like this. So it is dotted. And it's greater than, so that's going to be up. So I start at negative 2. I go up 1 over 2. Up 1 over 2. I'm going to use a dotted line. Shade up. So that's what my graph looks like. Okay? So 0, 0 is a good point, but 10, negative 10 is a bad point. It's not a solution. And you could plug those in to prove it as well. Again, just more work here to get it solved for y. Got to distribute negative 6x plus 2y less than or equal to negative 8. And then again, we're just solving. So box your 2y, draw your line down. Plus 6x to both sides. 2y less than or equal to, I want this mx plus b form, so I'm going to put the 6x first. Negative 8 second. Divide everything by 2. And this time I don't flip because I divided by a positive. So 2 is less than or equal to 3x minus 4. So my m is 3 over 1. My b is negative 4. Because this has a line under it, I'm going to use a solid line. Less than means shade below. So down 4 with a big dot. Up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. Solid line down through those. And this time is shade below, so I'm going to shade on this side. This is the underneath of that line. Let's do this one in class. Could shut the video a little bit shorter. Alright, number 8. This box up here just has some commonly used phrases that sometimes confuse kids, and so we want to be able to look at these and understand what they are when we read them, and so we'll know which symbol we're supposed to be using in the inequality when we're solving it. So when we see more than or greater than, and that's a pretty easy one, we know that's the greater than sign. When we see no more than 8 means it has to be less than or equal to that number. Okay? Less than is easy, that's going to be less than. No less than, though, is going to be like no less than 8 means that you want to be greater than or equal to 8. Exceeds means that you're going to be greater than a number. Cannot exceed means you're going to be less than or equal to that number. These are the two that confuse people the most. At most actually means less than or equal to, because if I want at most $5, then 5 is the biggest number I want, and I want less than that, 5 or less. And at least means greater than or equal to. A maximum means I want less than that number. Like if I want a maximum of $8, then that means I want 8 or less than or equal to 8. Same thing with minimum. Minimum is the opposite of what you would think. It is greater than or equal to. If I want a minimum of $4, that means I want 4 or bigger. And then the last one here, must exceed, means we want greater than. If you must exceed 21 years of age to get into this club, then you have to be 21 or you have to be, if you must exceed 21, that means you have to be 21, higher than 21 to be able to get into it. Okay? All right. 8 and 9 have us read some problems and work through and write some inequalities out. So it says, suppose you're shopping for crepe paper to decorate the school gym. Gold crepe paper costs $5 per row and blue costs $3 per row. So that's important. 5 goes with gold, 3 goes with blue. Your budget allows you to spend at most $48. So that means we're spending less than or equal to $48. And that's almost always the case when you're dealing with money, is that you can go less than or equal to your money. Write an inequality where B represents blue. So 3 went with B, so $3 for the blue. And is going to mean plus, and $5 for the gold. Has to be less than or equal to $48. Okay. Number 9, a company makes nylon and canvas backpacks. The profit of a nylon backpack is $3, so $3 is the profit on nylon. Profit for canvas is $10. The company's goal is to make a profit of $200. So if we want to make a profit of that, then we want 200 or more. So that is greater than or equal to 200. It's $3 for nylon plus $10 for a canvas, and we want to make greater than or equal to $200. That's the end of it.